So you will remember, no you won't remember where we were. I barely remember where we were, and I didn't have to take an exam. But we were here, we were doing the Keynesian model, which is our first simple story. And remember, what we're trying to get out of this is this idea of the multiplier. Then when autonomous spending goes up, output goes up by more than that. Right? And we saw the shift in the graph. Here we have planned aggregate expenditure goes down by 10. Autonomous expenditure goes down. This whole line shifts down by 10. And output goes down by more than 10. And that's the multiplier. You should be able to see it in the graph. And you should be able to tell the story. But you can't tell the story yet because we haven't had the story. So that's what we're having today. Okay, so that's where we are. So the fact that output falls when autonomous expenditure goes down, the line shifts down in a parallel way, output goes down by more than that. Okay? And the amount more, the number of times more that it goes down by, this is the multiplier. Okay? Okay. So our question is why? So in our little example, we had a multiplier of 5. That means a 10-unit decrease in autonomous expenditure reduced short-run equilibrium output by 50, 5 times the amount that autonomous expenditure went down by. It's going to relate to the marginal propensity to consume. So let's go through and do it. So initially, autonomous expenditure goes down by 10. So we can think, for example, that the government stops, people stop spending 10. So we'll think about people become pessimistic about the future. I start worrying that I'm going to lose my job, and so I start not spending quite as much. And the way we're telling the story here is that your autonomous expenditure falls, right? So the slope, the marginal propensity to consume in this little story stays the same, but the total amount you spend goes down. At each income level, it goes down by 10, right? If you have no income, you're not spending very much, but that goes down by 10. If you're getting huge income, you're spending loads, but you're spending 10 less now because you're a little pessimistic about the future. Right? At every level of income, your expenditure falls by 10. So initially, the initial effect of this is that we, as consumers, are spending 10 less, right? Which means we're not buying something, right? We're not buying haircuts. Right? I'll just let it grow a little longer. It's fine. I'll look like I'll be grand. But because of that, now we're not going to the barber. Now the barber feels poor, right? Because he used to have these customers that were spending this 10, and now they stopped spending that 10. He still has customers, but they're spending 10 less than they were before. So he feels poor, and so he does whatever a person that feels poor does. And our little story was that people's spending depended on their income. So his income went down by 10, he is going to reduce his consumption, right? How much is he going to reduce his consumption? Well, he has 10 less in income, and we said that his consumption was some autonomous consumption, plus this marginal propensity to consume, little c, a fraction, right? In this case, 80%, 0.8, times his income. And so if his income goes down by 10, his spending is going to go down by c times 10, right? So already we can see the multiplier, right? Because our little story is things get produced as people want to buy them. We have it's a whole economy. All it is barbershops all around. Barbershops up and down every high street. And that's how we all make our money. Pretend. All right. And so we stopped buying 10 haircuts. The barber felt poor. And he reduced his consumption of haircuts as well, right? By 8 in this case. Little c, 0.8 times 10. And so already we can see that output has gone down by more than 10. It went down by the initial 10 that we reduced our consumption, right? Because they only produce the haircuts when we go in to buy them. We're not buying them. They're not produced. And then the barber felt poor, and he stopped getting his haircut some as well. And so output went down by the initial 10 plus this 8. So it went down by 18 at this stage. Now, of course, we're not done here, right? Because there's some other barber that used to cut our barber's hair, and he has less income. And so he has less income by C times 10, the amount that our barber stopped getting his hair cut, right? And so that second barber, he's going to reduce his consumption by C times that amount that his income fell. Okay. And he was going to a fourth barber. What, second? Yeah, third barber. And so that barber, his income went down by C times 10, right? Because this guy's his income went down by 10, so his spending went down by C times that, so C times 10. And so this guy's income went down by that much, and so he reduces his spending by C times that, and so on and so forth. Okay. The really crucial bit of this story are these first two steps. If you can tell the story up to the second step, you understand the multiplier. Okay? And I can ask questions, and I probably will, like if something changes in the world. For example, if marginal propensity to consume is higher, instead of 0.8, it's 0.9. So little c becomes a bigger number. Still a fraction, but a bigger number. Is the multiplier bigger or smaller? Well, we're going to do the math for it in a minute. But at the moment, you could answer that question, right? Because you say, let's tell this story. Initially, people stop spending 10. We're buying 10 less in haircuts. The amount of haircuts produced goes down by 10. Then our barber feels poor. He feels poor by 10 because that's the income he didn't get. And he's going to change his behavior, right? And before, his behavior was 80% of his income. Right, so before, he reduced his spending by 0.8 times 10. So that's 8. But now his marginal propensity to consume is 0.9. Right? And so now, when his income goes down by 10, he reduces his spending by 0.9, by 9. 0.9 times 10. Right? And so his spending gets affected more. And so if the marginal propensity to consume is high, this second step is going to be bigger. Right? The second guy is going to reduce his consumption by more. And the third step is going to be bigger, and the fourth step is going to be bigger, and the 60th step is going to be bigger. And so the multiplier is going to be bigger. We can imagine, for example, a world where the marginal propensity to consume is 0. It's a world where we're all Bill Gates. And we all got way more money than we need, and our spending doesn't really depend on our income at all. We just spend out of our wealth anyway. Right? And so then we become pessimistic about our future. We cut back our spending by 10, and then the barber feels poor. His income went down by 10. And so he's going to change his behavior. Now that he feels poor, he's going to do whatever he does when he feels poor, but marginal propensity to consume is 0, so this just disappears. The second stage doesn't exist if marginal propensity to consume is 0, right? Because he doesn't change his behavior at all. So when he feels poor, he's sad about that, but he keeps doing the same stuff he was always doing, and so nothing gets knocked on to the next guy. Okay? And so in this case, the multiplier would be 1. When our autonomous spending went down by 10, output would go down by 10. But that would be the end of it. But if the marginal propensity to consume is higher, it's going to have a bigger knock-on effect because it's going to change the behavior of that first guy, or that guy in stage 2, by more. Okay? So the higher the marginal propensity to consume, the more it's going to affect that second stage and every stage down the line. Okay? So one of the things you should be able to do is I should be able to come up with a news story. Good luck with that. But suppose I come up with a news story and I say, does this make the multiplier bigger or smaller? You should be able to tell me. Right? So if I put, for example, income taxes into here, you should be able to tell me whether that makes the multiplier bigger or smaller by doing this kind of argument. If I say, suppose in this economy, instead of just buying Irish stuff, we also buy foreign stuff. Right? So we have an open economy where we buy a lot of our spending is on foreign stuff. Does that make the multiplier bigger or smaller? You should be able to figure that out. Okay? I'm going to leave those two to you, like write them down, like as things that are worth doing. I'll write them down on the slide here before I tell you the answer, but it is worth thinking about each of those. And again, all you have to do is think about these first two steps. What happens in those first two steps if we had an income tax? Does it affect the second guy's behavior more or less? If we had imports, like we're buying foreign goods, not just domestic goods, does that affect the second stage more or less? So give it a try, and then ask me next time, and we'll go over it. But I should be able to come up with any of these stories, like anything changed, and you should tell me how that affects the multiplier. Okay, so we want to look at how, where this multiplier comes from. And so I'm going to go through this math. I'm going to do it on a separate page. The things I want you to take away from this page is I'm using this little symbol delta to represent the change, a change. Right? It's a Greek letter, just means change, how output was before compared, how output is now compared to how output was before. And delta A is the change in autonomous planned expenditure. So we're shifting that line up and down by changing A. Okay. So I want to find the multiplier. And what do we got? We're going to look at the change in Y. Let's see. Change in Y is what? Well, initially, what have I done? I've ruined everything. Please come back. Come back. So hopeful. Okay, I need a new dongle. Okay. I can just see. I can just see my web page. I've been past Dean. I need a new dongle. Anyway. Okay, so what happens initially? The autonomous expenditure changes. Let's say it goes up this time. So people become optimistic about the future. At each level of income, they're spending more than they were before. So initially, they're buying more stuff, right? And as you buy stuff, that stuff gets created. So the change in output initially is just the change in A, right? Because we spend more, and so as we spend it, it gets created, because we have this barbershop metaphor for the economy. Things get created on demand. People walk into the shop, therefore we cut their hair. Right? So they spend 10 more, we create 10 more worth of haircuts. Okay? That's our story to start with. So that's great, but now our barber feels rich. He feels rich by the amount change in A, richer than he was before. And so he's going to change his behavior, and the way he changes his behavior is plus little c times change in A, right? Because he felt richer by this A, change in A, and so he increases his spending by c times that. When he gets 10 extra, he spends a percentage of that and saves the rest, right? So his spending, and this is our step 2 from before, goes up by c times change in A. And now the next guy feels richer by c times change in A, right? Because that's the amount that this second guy was spending at his barber. And so that barber now feels richer by that amount, and he changes his behavior by c times that. And so then this next guy feels richer by c squared times change in A, right? That's this c times that c times change in A. And he's going to change his behavior by c times that. C times that. And so on. So if we rewrite this, we get y equals change in A plus c, change in A plus c squared, change in A plus c cubed, change in A, and so on and so forth, into the infinite horizon. It circles around, and circles around. This circling around is, of course, what makes macroeconomics different from microeconomics, right? That when I stop spending, that affects your income. Therefore, you change your behavior, that affects someone else's income, and it circles around and around and around and around, right? This is also, you'll notice, the same argument they make when they want the government to fund a stadium, where they say, look, we'll have a stadium. People will come into the neighborhood. They'll buy stuff. Those people will be richer. Those people will buy stuff, and so on and so forth. Right? And therefore, you should give us money to buy a stadium because it's not just our business, but it's the entire community that gets affected by the beauty of sport. This is what they say. Right? Okay. So now we want to find out what this multiplier is, though. And so how much did output go up? Well, the way we're going to do this is I am going to write it this way. Change in y is equal to change in A plus C times change in A plus C, change in A plus C squared, change in A, C cubed, change in A. So what I'm doing here is I'm factoring out a C from all of this stuff. Like this thing is C times change in A plus C squared change in A. So I took a C out of that. I left this one the same. It's just carried down. But then for these other ones, I've just carried it down. So this one here is this. It just looks like, say, change in A in the brackets, but the C, of course, has been taken out of the brackets. So it comes to the same C change as A as before. And this one is this one here. It was C squared change in A before. One of its C's got taken out, and the other C is still left there. Then we get C squared change in A. That's just the same as this one, because one of the C's got taken out, and so on. We're taking each of those terms down and factoring out a C and putting it in brackets. But then we can notice that this bit in brackets is the same as, if I put blue brackets around all of this, it's the same as that. It's the exact same thing, right? It's change in A plus C change in A plus C squared change in A plus C cubed change in A plus C to the fourth change in A, C to the fifth change in A, and so on and so on and so forth. It's exactly the same infinite series. Okay. I know some of you had infinite series in high school, some of you didn't, but clearly it's exactly the same thing, right? And so since it's exactly the same thing, in the top one, I know that that whole rigmarole is just equal to change in y. And since this is math, I can use any legal math thing. I can plug that in. And so I can write this whole thing as change in y is equal to change in A plus little c times change in y. That second change in y is just all that bracketed stuff brought down because I know that it has to equal change in y from there. So this is, I'm going to put all the change in y's on the left. So change in y minus c change in y is equal to change in A. Just, I'll like belabor the point. 1 times change in y minus c times change in y is equal to change in A. And so 1 minus c change in y is equal to change in A. And then I can divide through by change in 1 minus c, right? Because I'm trying to find out how much does y change, how much does output go up when autonomous spending changes, right? And I can divide by 1 minus c because I know that 1 minus c is a fraction, because we're told that c is a fraction, it's a positive fraction. If c was exactly 1, I clearly can't divide by 0, right? Well, I can, but the mathematicians would kill me, and they're vicious, so we're going to leave that alone, right? We're not going to do that. And if it was greater than 1, then it would be dividing by a negative thing, and things would be goofy. So the only time we're really getting sensible answers out of this model is when little c is between 0 and 1. But we were willing to assume it, and everyone let me get away with that earlier on, and so you can't, no backsies. You let me get away with it, then we're stuck with it. But as long as we're confident that it's between 0 and 1, which empirically it is, again, no theoretical reason why it has to be, but empirically it is, and it seems reasonable. As long as it's between 0 and 1, I can do that division, and I get the change in y is equal to 1 over 1 minus c times the change in A. And let me put that in a little bit of brackets here. And this is our multiplier. And you can see it's a multiplier because, look, it's multiplying. It's a multiplying change in A, so it must be a multiplier by definition, something that multiplies. But in fact, it's saying like if autonomous expenditure goes up by 10, output goes up by 10 times this thing, right? And in this particular model, that's our multiplier. Now we should think, like, is this reasonable? So suppose, for example, we had a couple of examples. Suppose the marginal propensity to consume is 0. So that when we get a little richer, or get a little more income, we don't change our behavior at all. We don't spend any more at all, right? All bill, right? In which case, 1 over 1 minus 0 is just 1 over 1, and the multiplier is 1. So when our autonomous expenditure goes up by 10, output goes up by 10, right? So that seems reasonable, right? This is the story we had from before. If marginal propensity to consume is higher, so suppose, for example, C equals 0.5. Okay, put this in a side. C equals 0.5. 1 over 1 minus C equals 1 over 1 minus 0.5 equals 1 over 0.5 equals 2. The multiplier is 2. We start spending 10 more, output would go up by 20. Okay. But that's really low for a marginal propensity to consume. So what do we had? C equals 0.8. Then we get 1 over 1 minus C is equal to 1 over 1 minus 0.8 equals 1 over 0.2, which is equal to 5. Output goes up by 5 times the amount that autonomous expenditure goes up. And just for one more, C equals 0.9. I'm doing all the ones I can do in my head. I'm just saying. 0.9 gives me 1 over 1 minus C is equal to 1 over 1 minus 0.9 equals 1 over 0.1 equals 10. Multiplier is 10. Okay. And that's the sort of neighborhood we're kind of thinking. Now, I will say that I'm going to have to let you go, but I will say that a lot of you are going to be tempted to memorize this little formula. God help us, please don't. Like please don't. This is a super simplified version of the model. I can change the model in all kinds of different ways. You should be able to figure it out from this kind of story, right? I can change the model. I can put in income taxes. The multiplier is going to come out different. I can put in exports, imports. I can do all sorts of things that change the model. This is just the very simplest version of the model. There is nothing cast in stone or super important about this particular formula. It is not worth memorizing. It is not worth learning. It is, please, Lord, do not tattoo it on your elbow or anything. We don't need that. It is something, look, you can find this thing mathematically. Right? We know what this is, and the higher the marginal propensity to consume, the higher the multiplier is. Right? So what you want to get out of this is the story for the multiplier, the ability to find it, and the ability to tell the story and know what makes a multiplier bigger or smaller, not the particular formula, which is of no use to anyone ever. Okay, I'll let you go, and we'll continue next time.